Welcome back, and like I said, we're going to pick it up again from that point here and proceed or continue to talk about diffraction. We are saying that the amount of diffraction is given by this here, the sine of the angle formed by how far has the diffraction occurred. In other words, from that minima against the horizontal, how much of an angle is formed there. So sine theta is given by m times lambda divided by a, which is the size of the slit. So a is size of slit. Okay, and from this you can see that amount of diffraction is inversely proportional to the size of the slit, but amount of diffraction is directly proportional to the wavelength of the wave. Now, when we're looking at light waves, let's have a look. I took this question here so that we can use it for practice. It says here, a learner investigates the change in the broadness of the central bright band in a diffraction pattern when light passes through a single slits of different widths. She uses monochromatic violet light of wavelength 4 by 10 to minus 7 meters. The apparatus is set up as shown in the diagram below. Okay, so there is the setup. There is your single slit, okay, which is changed more often to see the effect on the size of the central bright band. There is your monochromatic violet light. Okay, next, define the term monochromatic light. What is monochromatic light? Monochromatic light, this is light of single frequency. Okay, so this is light of single frequency or single wavelength, monochromatic light. Write down the investigative question for this investigation. What we need to know is that the learner is looking at the relationship between the size of slit and the broadness of the central bright band. Okay, so if this is what she is looking at and this is what she's changing more often, what could be our investigative question here? It could be a question like this: how does the size of the slit affect the broadness? The broadness of the central bright band. You need to come up with a question that will try and tie the two variables you are investigating together. Okay, you are changing the size of the slit in order to check the broadness of the central bright band. Are you going to have a bigger broadness, smaller, whatever the case may be? Okay, so the size of the slit becomes your independent variable, because this is the variable you are changing to check on the broadness. Then the broadness becomes your dependent variable. It depends on the size of the slit here. Okay. Right, now, next, write down two variables that are kept constant during this investigation. Definitely, look, you are making sure that you are using a monochromatic light. Why are you using monochromatic light? You're using monochromatic light because you want to keep this variable here constant. Monochromatic light is light of single frequency, so this variable frequency is kept constant, or we say it is controlled in science. The next one that you are keeping controlled or constant is what? Is the distance of your light source to the slit. Okay, so the distance between the slit distance between the slit and the light source. Okay, those are the two variables that we're keeping constant. The learner now uses a narrower slit. How will the broadness of the central bright band change? Write down only increases, decreases, or remains the same. Definitely it's going to increase. Why? Remember, from here we have just said that the amount of diffraction is inversely proportional to the size of the slit. So if you make the size of the slit smaller, the amount of diffraction is going to go up. So there's your central bright band, the broadness of the central bright band is going to become bigger. All right. Next, calculate the angle at which the second minimum is formed if a slit of 2.2 by 10 to minus 6 meters is used. Now here you just use your formula, sine theta equals to m lambda over a. Substitute everything. Sine theta equals second minima, so your m is 2 times the wavelength is what? 4 by 10 to minus 7. Remember, as given to us earlier on, divided by the size of the slit, which is 2.2 by 10 to minus 6. And then whatever you find here, the theta will be what? Will be sine inverse of whatever value you get there, and then you have your angle. You have answered your question. So this helps you to see how you make use of Huygens principle to solve problems related to diffraction. Hope you enjoyed that. Of course, that brought us to the end of the lesson today, and as from me, Tinyiko Wamachab Kosa, is a bye-bye.